Sample problem 3.7. Determine the number of water molecules and the number of hydrogen and oxygen atoms in 3.26 grams of water. Determine the mass of 7.92 times 10 to the 19th carbon dioxide molecules. So what this problem does is it takes what we did in sample problems 3.5 and 3.6, combines them together. It's a combination problem. So let's try part A here. So in part A, we have 3.26 grams of water. And what we want to do is we want to find the number of hydrogen atoms and the number of oxygen atoms. Well, this should be lots of fun. Here's how we go about it. First, we need to do a conversion of mass of water to moles of water. And we're going to use the molar mass to do that calculation. Okay, we saw that in the previous problem, that if you have the mass, you can convert to moles by using the molar mass. Next step is once we've got moles of water, we're going to convert it to the number of molecules of water. And we're going to use Avogadro's number, 6.022 times 10 to the 23rd, to do that conversion. Once you've got the number of molecules in water, then what we can say is that one molecule of water has 2 hydrogens, and one water molecule has 1 oxygen. So we can figure out those numbers pretty easily. So let's go through this first. First things first is that for water, we need to know what its molar mass is. Well, there's 2 hydrogens and 1 oxygen. So the molar mass would be 18.02. Where did I get that number? I got those numbers, 1.01 and 16.00, from the periodic table. Then I used the chemical formula of water, H2O, to figure out that that would be 18.02 grams. So now we have the molar mass of water. So I'm going to write it down as 1 mole of water equals 18.02 grams of water. Okay, now that we've got that, let's do the conversion. 3.26 grams of water, and we're going to convert that to moles. So notice I'm putting the mole on the top and the grams on the bottom. Why? Because we have grams here. We want to get rid of grams. So grams of water divided by grams of water will give us moles of water. So the calculation is 3.26 over 18.02, and that is 0.18091. Oops, sorry. .1809. And that would be moles of water. Next step, we're going to convert moles of water by using Avogadro's number to convert that to molecules of water. Avogadro's number is 6.022 times 10 to the 23rd. Okay, so 0.1801 moles of water. And then we're going to multiply it by Avogadro's number. Same thing we just did in sample problem 3.5. In this case, it's molecules. Okay, that's going to get rid of moles of water. That's why I put moles on the bottom and Avogadro's number on the top. So times 6.022 times 10 to the 23rd, and we now have 1.089 times 10 to the 23rd. Molecules of water. Okay, we're not there yet because we want to know the number of hydrogen and oxygen atoms. But take a look at the formula for water. Water has 2 hydrogen atoms per 1 water molecule. And how many oxygen atoms does 1 water molecule have? That's right, 1. Now you can go through this formally. If we have the number of water molecules, the number of oxygen atoms would be the same, right? Because every time you have one water, you have one oxygen. So oxygen atoms would be the same number, 1.089. So there's one answer. And then for the hydrogen, it's twice as much. So you would just say, look, we're going to multiply 1.089 times 10 to the 23rd, and we're going to multiply that by 2. So times 2, and you get 2.179, so 2.18 times 10 to the 23rd hydrogen atoms. Okay. Now, I didn't round the oxygen correctly. It should be 3 sig figs because we had 3.26 grams of water to begin with. That's 3 sig figs. So let's round it to 1.09. Okay, so there's our answer for part A. There's 2 answers. Now what we want to do is we want to go through the second part. So what I'm going to do is select some space here. Clear up some space, and let's do part B. Part B says that you've got not 7.92 times 10 to the 19th carbon dioxide molecules. And they want us to find the mass, okay? So the logic here will be, we've got the number of molecules. We're going to use Avogadro's number to find the number of moles. And then we're going to use the molar mass to find the mass. Okay, that's the logic here. In fact, those are the 2 types of conversions that we're learning in these sections, which is how do you use Avogadro's number to get the number of moles from molecules or vice versa, and then how do you use the molar mass to go from moles to mass or vice versa. That's really the whole idea here. Okay, so let's try this example. So we need Avogadro's number. Well, that's easy. Could look that up, find that. So 1 mole is 6.022 times 10 to the 23rd molecules. We have the number of molecules, so we want to convert that to moles. So 7.92 times 10 to the 19th CO2 molecules. And then we want to convert it to moles, so mole goes on top in the numerator. We're using Avogadro's number as a conversion factor. So the molecules cancel. So 7.92 times 10 to the 20, times 10 to the 19th. Let me clear that out. 7.92 times 10 to the 19th divided by Avogadro's number. And you get 1.315 times 10 to the minus 4. Let me just check that. 1.315 times 10 to the minus 4 moles CO2. Once you've got the moles of CO2, you convert that to grams by using the molar mass. So for carbon dioxide, there's 1 carbon. And that weighs 12.01 grams. Again, you're getting that from the periodic table. 2 oxygens. So that gives you a total of 44.01 grams. So 1 mole CO2 weighs 44.01 grams of CO2, if you want to write it that way. Okay? So now we have the number of grams. We have the number of moles. 1.315 times 10 to the minus 4 moles of CO2. We're going to convert this to grams. How do you convert it to grams? You put the grams in the top, and you put the moles in the bottom. So you're multiplying by Avogadro's number. We should get, I'm sorry, not by Avogadro's number, by the molar mass. So we should get grams of CO2. So 1.315 times 10 to the minus 4 times 44.01, and you still get a pretty small number. It's 5.787 times 10 to the minus 3. I'll just round it to 5.79. grams of CO2, right? Grams CO2. So there's our answer for part B. Okay? So practice these. Practice 3, 5, 3, 6, 3, 7. Gram to mole conversion, mole to gram conversion, number of atoms or number of molecules to moles, moles back to atoms and molecules. And then you can do the full set of all of these conversions.